Hello everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So today in this session, we are going to discuss about the application of first order and first degree differential equation. And also we will see one example on this application. So what is that application we are going to discuss here? The Newton's law of cooling is the first application of the first order first degree differential equation, and another application is also there, that is law of natural growth or decay. So in this session we will discuss about the Newton's law of cooling and we will discuss the problem or one example on Newton's law of cooling. So first of all, we'll see what is the actual statement of Newton's law of cooling. So see the statement here, the rate of change of temperature of the body, right, is proportional to the difference of the temperature of the body and that of the surrounding medium. So generally, the rate of change of temperature, that means the temperature of a body is usually depends on time, right, and this is proportional to the difference between the temperature of the body and the surrounding medium. So here generally we are taking our surrounding medium is generally air, right. So we are taking the air temperature also, and now we are going to prove of this, right. See the proof of this. So now let us take theta be the temperature of the body at any time t, right, and theta naught be the temperature of its surrounding medium. So theta be the temperature of the body at any time t and theta naught be the temperature of its surrounding medium. The surrounding medium is generally we are taking the air temperature. So according to the statement of Newton's law of cooling, rate of change of temperature of a body. Rate of change means d theta by dt, right. So d theta by dt is proportional to difference between temperature of the body and the surrounding medium. Difference between the temperature of your body and the surrounding medium is nothing but theta minus theta naught, right. So what is the equation we are getting? D theta by dt is proportional to theta minus theta naught, and now we have to take the proportionality constant. So that is d theta by dt is equal to minus k into theta minus theta naught. So why we are taking here the minus k as a proportionality constant? Since here we are discussing only the cooling cases, so that you have to take the proportionality constant is a minus k. So now this is the first order first degree differential equation. After solving this equation, so we will get log of theta minus theta naught minus is equal to minus kt plus c. How we are getting this log of theta minus theta naught is equal to minus kt plus c is, so see the solution once here. So what is the equation exist here? D theta by dt is equal to minus k into theta minus theta naught. So now we are going to use the method of variable and separable. So d theta by theta minus theta naught is equal to minus k into dt. So now the variables are separated, and now you have to integrating on both sides. Integral d theta by theta minus theta naught is equal to minus k into integral minus k into dt plus c. And now the integration with respect to theta here, Since theta naught is a constant, usually air temperature is always constant. So that now the integration of theta minus theta naught 1 by is, so log of theta minus theta naught is equal to minus k is a constant, integral d t is nothing but t plus c. So this is the equation or exist, and sometimes we are taking the another equation, that is log of theta minus theta naught is equal to minus kt plus c. We are taking constant is here, log c also we are taking. So this is also the another formula to find the temperature of your body at any time t. And also sometimes we are giving the time. You have to find the temperature, and sometimes we are giving the temperature, we have to find the time. So now this formula will gives the temperature of your body at any time t. Suppose if the time is given, you have to find the theta. Suppose if theta is given, you have to find the time. So for those two cases, you have to use any one of this formula. Right, now we will see the one example or one problem on Newton's law of cooling using the first order first degree differential equation. So now see the question. A body is originally at 80 degrees centigrade. So that means originally means initially. Initially, the temperature of the body, that is theta is equal to 80 degrees centigrade. So initially we know that always the time is 0, right, and cools down to 60 degrees centigrade in 20 minutes. So another conditions also given. So what are the another conditions here? So within 20 minutes time, so the temperature of theta or the temperature of the body is 60 degrees. So theta is equal to 60 degrees centigrade when the time is 20 minutes. Right. So if the temperature of the air is 40 degrees centigrade, that means theta naught is equal to 40 degrees centigrade. So that is the air temperature. So this air temperature is a constant. And what we have to find here? So find the temperature of the body after 40 minutes. So that means the time is given. So what is the time value is given? So t is equal to 40 minutes. And we have to find the temperature of the body. Right. So these are the conditions was given in the problem. And now we have to find out the value of theta when the time is equal to 40 minutes. Then how can we find? See the solution now. So initially time is equal to 0. At the time, what is the temperature is given? 80 degrees centigrade. And also given theta naught is nothing but the air temperature. The air temperature is 40 degrees centigrade. So by Newton's law of cooling, log of theta minus theta naught is equal to minus kt plus, so here I am taking the constant as a log c. And now we are going to simplify this equation. So you have to bring this log c to left side, the log of theta minus theta naught minus log c is equal to minus kt. So we know that log of theta minus theta naught minus log c is nothing but log a by b. We have the formula. So what is that formula? Log of a, that is log a, minus log b is log of a by b, right? So now we are going to use this formula. Log of theta minus theta naught by c is equal to minus kt. And now you have to bring this logarithm to the right side. So this turns to the exponential. So theta minus theta naught by c is equal to e power minus kt. So after the simplification, this gives theta is equal to theta naught plus c into e power minus kt. So now you have to take this formula is a 1. So first you have to take the initial conditions. So these initial conditions you have to substitute in this first equation. So what is the theta given? 80, right? So 80 is equal to theta naught is a 40 plus c into e power minus k into the time is 0. So 80 minus 40 is equal to c, since e power minus 0 value is a 1. So therefore the value of c is equal to 40. 80 minus 40 is nothing but 40. Right, the value of c is equal to 40. Again, this c value you have to substitute in the first equation. Right, therefore theta is equal to, what is the theta naught is 40 plus the c value is also 40 into e power minus kt. So now you have to take this equation is 2, and now also another conditions is given. What is the another conditions is given? Theta is equal to 60 degrees centigrade and the time is 20 minutes. So again substitute this theta and the time value in the second equation. 60 is equal to 40 plus 40 into e power minus k into the time is 20. And now to simplify, after that it will give the k value. 60 minus 40 is 20 is equal to 40 into e power minus 20 into k. So this 20 is equal to 40, so that this cancel 2 times, and this implies the 1 by 2 is equal to e power minus 20k. So the negative power of exponential value is 1 by 2, and now we are taking the positive exponential value, that is e power 20k. That means we are taking the reciprocal of this, right? E power 20k value is 2. Then bring this exponential to the right side, so that exponential is turns to the logarithms. 20k is equal to log 2. And now the value of k is equal to 1 by 20 into log 2. So this is the value of the k. Again here the k value you have to substitute in the second equation. You have to substitute in the second equation. So therefore the theta is equal to 40 plus 40 into e power minus 1 by 20 into log 2 into t. So you have to take this equation is the 3. So what is the value we have to find out? We have to find the value of theta when the time is 40 minutes. Theta is nothing but the temperature of the body. So that values we have to substitute in the third equation. It will give the temperature of the body when the time is equal to 40 minutes. Right? The T is equal to 40 minutes. So you have to find the value of the theta. So you have to substitute these values in the third equation. What is the third equation? Is theta is equal to 40 plus 40 into e power minus 1 by 20 into log 2 into t. So now we are going to substitute the value of t here. 40 plus 40 into e power 1 by 20 into log 2 into t value is 40. So now cancel with this 2 times. So this is 20 and here the 40 is 2 times, it's cancelled. So this is equal to 40 plus 40 into e power minus 2 log 2. So after the simplification, it will gives the theta value. So now see that the simplification here, 40 plus 40 into e power log 2 power minus 2. So e power log x is x, we know that. So 40 plus 40 into 2 power minus 2. So 2 power minus 2 value is nothing but 1 by 4. So 40 plus 40 into 2 power minus 2 is 1 by 4. So this is 10 times cancelled, and now 40 plus 10 is equal to 50. So this is equal to 50. So theta is equal to 50 degrees centigrade when the time is equal to 40 minutes. So that completes the solution of the given problem. So what is the problem values was given? That is when so what is the initial value? Initial is 80 degrees centigrade at the time t is equal to 0, and the air temperature is a constant, that is theta naught is a 40 degrees centigrade, and also given the another conditions or theta is equal to 60 degrees centigrade when the time is 20 minutes, right? And finally what we find, so theta we did at that the time is 40 minutes, right? So in this session we discussed about the statement of Newton's law of cooling. So what we have seen in this session, so statement of the Newton's law of cooling, and we proved what is the formula of the Newton's law of cooling, and we did the problem on Newton's law of cooling. So that's all for today's session. Thank you.